What's up everyone? Welcome back to another video. Today we're going to be doing another LeetCode problem and it's going to be on tree. Once again, I'm going to read out the prompt, explain it, write out the code, explain the code, and finish it off with time and space complexity. Okay, so what here we have is 101 symmetric tree. Given the root of a binary tree, check whether it is a mirror of itself. So set symmetric around its center. And here's what we have for the examples. We have the true, which if you're looking at it, yeah, they're mirrored. And then false, you know, because it's not mirrored. Okay. All right, so the basic idea is it's just asking, is the tree a mirror of itself if you fold it in the middle? Right, so we have a line here, and you just fold it. So what we have to sort of think is like are two subtrees like mirror images of each other? Are two subtrees mirror images of each other? Okay, so we want to look at different conditions. So we have two subtrees, let's call it T1 and T2, and they are mirrored if number one, both are null. So if both are null, that makes perfect sense. There's nothing on left, there's nothing on right, it is a mirror. Number two, we also want to know that if one is null while the other is not, then that means it is not a mirror. We want to have that condition too, because if one side has nothing but the other side has something, you can just print out false, right? And then for the last one will be where both sides have values, and that's when we start checking, are the values equal to each other to create the mirror. And so for the third part is both have value or no, node, or both are not null. There we go. So when that happens, then in here within the both having values inside, we want to check the value. And the first one is obviously we want to check the T1 value. Is it going to be equal to T2? After that, we want to check whether the T1.left is going to be equal to T2.right. And finally, we also want to do T1.right. Is it going to be equal to T2.left? Like that. So if we look at example 1 here, number 1, T1 value and T2 value are the same. T1.left has a 3, while T2.right has a 3. T1.right, T2.left, they are also, the value are also the same. And so that's the whole base recursion stuff. All right, so now let's write down the code. First, we want to check whether or not the root is going to be equal to null. And if the root is empty, then we just return true. Because even if it is empty, we want to return it true because technically it is symmetrical. Okay, now let's write a helper function. It's gonna help us identify whether it is a mirror or not. And this is the part where I'm gonna be doing the T1 and T2. So T1, T2 for tree node, and the inside, here's what we're gonna do for all three of the cases. So first case 1, both null, which means mirrored. So T1 equals null and T2 equals null. Then when that happens, you want to return true because that's what we mentioned. Now here's the case 2, where one null, one not. So when that happens, not mirror. So T1 equals null, and instead of and, we do or. T2 is equal to null. So if say if T1 is null but T2 has a value or a node inside, then you want to just basically return false. Like this if statement would become true, so we're going to return false. Okay, so now down here, we're going to be doing the case 3, where both are not null. And now this is the part where we're basically going to match the values. Matching values right here. Okay, so all we have to do is, first things first, you want to do t1 dot t1 value. If t1 value is not equal to t2 value, then return false. And this part basically is answering the number 3 part A, right? If it's not equal to the value, to the t2 value, then you have to return a false. Now what we're going to do is we're going to return itself, which is mirror, and we're going to return it with t1 dot left with t2 dot right, and I'm going to write is mirror again with t1 dot right and t2 dot left. So you have to think of the first one as like the outside pair. As you can see, we have the left and we have the right here. And then the second part will be the inside pair, which is the 4 here and 4 here. Okay? So, and then after all of that, you want to come back here and basically return, let me see, it's the private, oh, sorry, this part needs to be here. Whoa, is that right? Yeah. Can I just do the, oh, I don't know what's the control for this, but it's whatever, it's fine. Wait. Uh-oh. Oh, actually, nope, not uh-oh. I'm fine. There we go. I don't know why I was writing it inside the public is symmetric. But basically, once the is symmetric is done, you want to return the whole thing. Well, you want to return is mirror with the root dot left and root dot right. There we go, and then finish it. And that should be it. Now we're going to take this part out because we have answered everything, and we're going to run it just to make sure. Perfect. Let's see, case 2 also works. Yep. Okay, so basically, first things first, and now I'm going to be explaining the code. So what we have here is basically right here, we have the function that the LeetCode is going to call. Right here is the base case, which just says like if the tree is empty, an empty tree is basically symmetrical by definition. It's a mirror of itself. So we just return true. Right here, for let's say if the tree is not empty, right? It's symmetrical if and only if the left and the right subtree are mirror. Okay, and that's where we have, this is why we are calling our helper function for the on root left and root right here. Okay, so all right, so right here what we have is the is mirrored method, basically the core recursion. This function compares basically the two subtrees. So case 1, both are null. If both node are null, that means both subtree are empty, and that's basically symmetrical. And so, you get the idea. Case number 2, like I said, if one is null, the other is not. If we get here, it means both are not null, right? Because the case 1 already handles it. In this case, it means exactly one is null and the other is not. So when that happens, that's basically asymmetric, so we have to return false for that part. However, if that case also doesn't go through, then we are on the case 3. Now this part is where both T1 and T2 exist, so their value must be the same to be symmetrical, right? However, if the node value is different, then the trees are not mirror images. And that's why we have to return a false. And then on the bottom here is this line is basically where we are doing the mirror logic, because for two trees to be mirrors, t1.left must be a mirror of t2.right, and then t1.right must be a mirror of t2.left, right? So, and now I'll basically do like a quick walkthrough with this example one. So first things first is just gonna call is symmetric for the root, and then now we're gonna return is mirror for the root dot left and root dot right, which is basically 2 and 2, right? So 2 and 2, and we go down here. We're gonna look at this, and so here we have, the both are not null. Case 2, it doesn't go through either. Let me quickly, there we go. And then for case 3, they are matching, because if they're not, it'll just return false, which I need to get rid of some of that space. And so if it goes through all of these cases, then we continue with the recursion. Now it's going to check T1, which is node 2 dot left, which is 3, and T2, which is again node 2 but on the right side. Again, it's going to go through for the is mirror. Is it null? It is not, so we skip. Is one null, one not? Nope, so we skip. Matching values, they are matching, so we skip this if statement as well. And then we're going to make sure, and also we have to check for the T1.right and T2.left, right? So if both this part and this part returns, then it basically tells you that yes, both sides are basically true. And so it sort of would look something kind of like this. Is mirror 2 for the left, and then 2 for the right, and it is equal. Is mirror 3, 3, because we have 3 here on the left and 3 here on the right. And is mirror for 4, 4, because T1.right, T2.left, which basically shows that it's true and true. So true and true is going to be equal to true. And that's it. However, if, say, one side, the mirror is a 3, just by looking at here, for example, right? Well, for this part, it will basically show that that one of the cases is not true. And so when that happens, it will just automatically return false. But for this part, let's say the value is something else, and it like 4 right here, then this becomes false. A false and a true is going to give you a false instead. So, and of course, if both sides are false, it will also give you a false. So yeah, that's sort of like the best example, the best walkthrough I can kind of just give, I'm not sure what else can I say, but hey, the case works, and I'm just going to quickly submit it to make sure it works. And it works. There we go. Perfect. Every case it passed, and yeah, there it is. Let's do a quick talk on this complexity for time and space. So what we want to do is let n be number of nodes. And so for time, it will be big O of n, because we have to visit each node once. And then for something like space kind of depends, right? So we have obviously the recursion depth, which is gonna show which is gonna be the tree height for h. So that's what we have, and it has two cases. Our worst case is basically when the tree is skewed. So again, like a linked list, if that happens, then it will be big O of n. Best case scenario is when it's balanced, and it'll give you big O of log n. And that's basically it for the time and space complexity. All right, thanks for watching. If you want to see another side of me that isn't always about computer science, then check out my other YouTube channel and come and watch my Twitch, where I play a bunch of competitive games either by myself or with my friends. And not only that, but I do have my Discord available just in case if you wanted to add me, either to just talk about anything, whatever you want, or have some kind of question from my video. Thanks.